So now that we have learned about frequency, these are some examples of frequency range. Alright, power line frequencies basically means that which frequency that your power rating is, which means like whatever your power plug point is and all that, it actually goes by a certain frequency and all that. So usually it goes by 50 to 60. Alright, the audible sound, basically what frequency that this is the frequency range that we are exposed to that is within our human hearing capability, because anything lower it might be captured by your cat or dog and whatever other animals, but not by us, even the higher one and so on. Alright, so this is just like some examples on what you would know on how the frequency range goes, because for certain different application we have different frequency range allocated for it. So basically that's about it. Okay, so period, like I said earlier, right, we know that F is the frequency and F is actually the number of cycles per second. Alright, so period T is related in terms of this formula over here, because T, capital T, because small t will indicate the time. So capital T period is equal to 1 over F. Alright, it's in inverse of the frequency, and usually it also means that it's the duration of the one cycle. Alright, so if you're given a graph and then you're given the time and all that, and they ask you to get the frequency or the period, then it should be easy for you, because you will need to know that period T is actually the duration or how long it takes for your signal to complete its one cycle. Alright, so as far as you know that, no issue for you to get the T, and definitely no issue for you to get the F. Alright, and the unit for T is in seconds. Alright, because we're talking about duration of one cycle over here. So hopefully you guys are clear with this. Alright, so we move on to the next one, which is the amplitude, right? So over here you can see that we always use sine wave, but that's also like an easy representation of how we just get consistent with how the signal is, so that it's easier for explanation and so on. Alright, so for example, the amplitude. How do we know of the amplitude? Alright, so basically it says that amplitude is the distance from zero crossing to peak. Basically, it basically means that this is zero, whatever your signal is, the tipping point here, the top part here, this is what we call the amplitude. If this is 0 and let's say this is 3 volt for example, so your amplitude is actually 3 volt. Alright, but there's also one thing that sometimes that you see that some other terminology where they go by peak to peak. Alright, peak to peak is a term to indicate from the top end until the bottom end. So for this over here, this part over here, it's actually the distance between the top peak up until the lower peak. Alright, that's why it is called peak to peak. Alright, so if for example in a particular question they actually say that it's actually 6 VPP. Alright, just for example, let's say it's 6 VPP. Alright, P and P basically usually means that is peak to peak value. Alright, so you know that if it is represented as such, alright, this means that your amplitude is actually 3 volt. Alright, because 6 VPP indicates that from here to here it's actually 6. Alright, so if you are to indicate what the amplitude is, it's going to be 3, because you just divide it into 2 and that's where you get the amplitude. Yeah. Alright, so just a representation of how we indicate a sine wave. Okay, so as we know, sine wave is actually a shape of a slinky, like an S shape like that. So it starts from one end, from 0, and then ends at 0. Alright, so usually if you use, let's say this is E here, it can be F anything, it can be I, it can be V, it's just a notation, yeah. So it's actually indicated by EM sine alpha here. So EM is basically the amplitude. Do you notice that? So usually at any given point of expression, the top part, if you're given a value here, this actually indicates the amplitude of the signal. Sine alpha basically just indicates that you have a signal there, a sine wave, alright? So at given point of time, E basically means that just some terminologies that you will need to be familiar with. So it can be an instantaneous value, which means at any point of time, alright? At any point of time that you actually need to know what the value is, alright? It could be this point here, it could be this point here, it could be this point here, and how you actually get the value would be through this one, alright? The expression. Like we said, amplitude, which is also considered the maximum value, alright? This part over here, the alpha, is actually just the angular position of the coil, alright? Could be the signal and so on. So an equivalent representation of it is actually omega t, alright? Omega t, as some of us would have known, omega is actually equivalent to 2 pi f, alright? So basically whatever that you see here can also be represented as em sine 2 pi ft. Alright, so if you're given a particular expression at any point of time, you can actually use this as a gauge or a notation to actually compare it to whatever expression that's given to you, alright? So for example, if you have E equals to 3 sine 6t, alright? So just for example, then you have 3 sine 6t, alright? This is just an example. So you know that at any point of time, let's say like this is the question that's given to you, then you know that your EM or your amplitude is actually 3, alright? Sine stays the same, but you know that if sometimes, let's say they ask you to get the frequency, you know that you can take 6 and compare it with and make it equivalent to 2 pi f, and that's how you would manage to get your f, alright? So this is basically just sort of like a normal mathematical equation. Phase difference. Phase difference refers to angular displacement, alright, between waveforms of same frequency. You will look at it easier later in the next slide, alright? For example, if your angular displacement is 0 degree, alright, displacement is basically like when you have two signals together, you want to see how far off away in terms of degree that they are away from each other, alright? So for example, if both signals are in phase, it literally means that the displacement is 0. Let me show you what it actually means here, alright? So for example, you have a voltage signal, you have an I signal, but you see that both signals are starting at the same time, right? So this means that there is no any phase difference between them, or that it is actually 0 degree phase difference, and that's why the term that we use for this is that they're in phase of each other, alright? But in contrary, otherwise, if there is a difference in terms of the degree, right, it means that it's out of phase, alright? And then when something is out of phase, it literally means that one waveform will lead and one waveform will lag, alright? I'll show you what this means over here. So like you said over here, see there's difference between these two, right? Because for here you can see that these two signals, they do not start at the same time. Obviously there is a phase difference between them, right? Same goes for this one, alright? So this is the phase difference that they're talking about here. And how do you know? You usually compare where the two signals start, alright? If this is where it starts, and then you take another signal and take where it starts as well, and this will be the phase difference, alright? So in this case, actually you see that current actually starts first, right, before your voltage, and therefore we call it as current leading the voltage. But like for example, for this one, you can see that your V actually starts at 0 at 0, but your I only starts at 0 at some point over here. So the phase difference is over here, and since V starts first, we say that V leads I, or current lags voltage. So that's another way for you to say it, right?